Hey guys, welcome back. For today's video session, what I'm gonna do is to introduce to a new sensor that is SI1132. Now let's have a look over this sensor in a better way, and for that log on to the website that is controleverything.com and here search for this particular sensor that is SI1132. Now what we got for the sensor, that it's a UV index ambient light sensor, and these are some of its features you can see on my screen. Also, you can purchase the sensor from here. Now, I'm going to collect the sensor that is ambient light sensor SI1132 and interface that with the Raspberry Pi and a Java code. And to get the Java code, I will be going on the resource tab, and here comes the Java code sample. Now, I will be downloading the Java code sample as a zip file from here, just like that. And I will be have the opportunity to download the code from another source, that is github.com, and the repository that is control everything community. Now what we require is to make some connections for the hardware to have a very good look over the sensor working and functioning. Let's have it. Now coming to the hardware section, first of all the requirement is of a Raspberry Pi, which you are able to see on my screen, and this here is an I2C shield. It's available on the website controleverything.com, and the reason we are using this shield is to make connections with other I2C devices, and the connection should be a lot easier. That's why. Now the next part is to gently place this I2C shield over the GPI pins of the Raspberry Pi and make a connection. Now what we require is our sensor that is UV index ambient light sensor SI1132, and this here is a connecting cable. Make the connection of the cable and the sensor, and while making this connection, make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and same goes for the I2C shield. Now to power up the Raspberry Pi, what we require a micro USB cable just like this, and gently insert it over the power jack. The last part is to provide the internet connection, and we have two ways. The first is an Ethernet cable, which you can see on my screen, and gently insert it over the Ethernet jack or LAN cable, as you can notice. Now the second part is that if we don't have the first part, that is the Ethernet or the LAN cable, we can have the opportunity to make the connection via a nano adapter wireless, which you can see on my screen. Here it is. Now we are done with the internet connection. So all the connections we need to put up this setup, we are done. Now what we require is to have a look over the code, and let's interface. Now coming to the interfacing part, for the Java code, what we require is to log in to github.com, and here we have to search for the repository that is control everything community, and here we go. As you can see, this is the ambient light sensor that is SI1132 UV index, and this is the Java code we are looking forward. But let's have a look over the instructions we need to follow. It says that we have to download and install Pi4j library on the Raspberry Pi, and this link pi4j.com is the link from where we can have all the relevant information regarding the installation steps for Pi4j library. Please note it down carefully. Now what we're going to do is to compile the Java code, and this is the command for that, and this command is to run the Java code for SI1132. Now get back to the Java code. As you can see, it's a .java extension file. Now coming to the code, the first step, as you can see, we have the importation of some of the libraries, as you can see, which we will require, and we have created a public class named SI1132. Now here we have bus.getDevice, which will show the address of the sensor, that is 0x60, and we have enabled UV index measurement coefficients and the command for writing the data here like that. Now the next part is to select param WR register, and we are enabling UV visible and IR, and it's 0x17 0xF0. Next we are selecting command register having address 0x18, and we are sending the command to select CH list register in RAM, that is 0x01 or with 0xA0. Then we are reading 1 byte of data from the register, that is 0x2E, as you can see here. Now we are selecting INT output enable register having address 0x03 and sending the command for INT pin drive 1 low, as you can see, that is 0x01. Then we are selecting ALS input interrupt enable register, as you can see, 0x04, and asserting INT pin wherever visible or UV measurements are ready, that is 0x01. selecting HW key register having address 0x07, sending the command for the default value, that is 0x17. Then we are selecting the param WR register having address 0x17 and sending the command for small IR photodiode, that is 0x00. Then we are selecting the command register, and that is 0x18, sending and selecting ALS IR ADC mux register in RAM having address 0x0E or with 0xa0. Then we are selecting param read register having address 0x2E and reading the 1 byte of data, that is response. Similarly, we are selecting param WR register, and that is 0x17, and setting ADC clock divided by 1, that is 0x00. Then selecting command register having address 0x18 and sending the command to select ALS IR ADC gain register in RAM, that is 0xC1E or with 0xa0. Then from the param read register, that is 0x2E, we are reading 1 byte of data, that is the response, as you can see. Now again sending the command, and first of all selecting param WR register having address 0x17, setting the ADC clock 511, now that is 0x70. Then we are selecting the command register having address 0x18 and we are sending the command to select ALS IR ADC counter register in RAM, that is 0x1D or with 0xa0. Then again from the param read register, that is 0x2, we are reading 1 byte of data here, just like that. Now we are selecting param WR register next, and that is 0x17, setting ADC clock divided by 1 having address 0x00, selecting command register having address 0x18 and sending the command to select ALS visible, that is VIS ADC gain register in RAM, that is 0x11 or with 0xa0. Then we are selecting param read register having address 0x2E and reading 1 byte of data from that very register. The next part for the writing section, we are selecting param read register, param write register, as you can see, having address 0x17 and sending the command for high signal range, that is 0x20. Then selecting command register, that is 0x18, sending the command to select ALS IR ADC MISC register in RAM, that is 0x1F or with 0xa0. Then again from the register, that is param read register 2E, we are reading 1 byte of data. Next part is to select param write register having address 0x17, as you can see, select sending the command to set 511 ADC clock, that is 0x70, selecting the command register, that is 0x18, selecting ALS visible ADC counter register in RAM, that is 0x10 or with 0xa0, selecting param read register having address 2E and reading 1 byte of data from that. The last part is that for the writing section, that is selecting param write register having address 0x17 and selecting the high signal range, that is 0x20. Then we are selecting command register having address 0x18 and we are sending the command to select ALS visible ADC MISC register in RAM, that is 0x12 or with 0xa0. So we are done with this part. Now after that we are selecting param read register having address 2E, 1 byte of data we are reading from this very register. So we are done with the writing section, we have all done. Now what we require is to read the data back, the response from the sensor. Now we are selecting command register having address 0x18, having starting ALS conversation, that is 0x0E, and we are reading 4 bytes of data, that is visible and IR from the register, that is 0x22. Then we have the conversion for this particular data, which we have seen the relevant information regarding the conversion formulas, the procedures in the datasheet for SI1132. Then again we are reading 2 bytes of address from the sensor, that is 0x2C for the ultraviolet data. Conversion of the data takes place here. At the very end of our code, we have the output data on the screen, which you can see as the ambient light of source, IR of the source, UV of source, and the unit is lux. So this is about the code. Now what we're going to do is to have a look over the working. Let's have it. Now coming to the working environment, first of all we have to copy this entire code, as you can see on my screen, the Java code, and then what we have to do is to open up the terminal regarding the Raspberry Pi, and here we have to create a new file, that is SI1132.java as the extension, and here we have to paste the entire code, and then we have to save the code, as you can see on my screen, and this is the command to compile the code, as you can see on my screen. And here we go, it's done. Now this is the command for the work running of the code, the Java code. And here we go, as you can see, we have the ambient light of source, IR of the source, and the UV of the source. And again, when we are sending the command, you can see it's almost constant because there is no object interference regarding any source. But when I place some object over the sensor, you can notice there is a change regarding the values for ambient, IR, and the UV source. Yeah, just like that, as you can see, it's decreasing, there is a change. But when I place some light source over the sensor, you can see the increase in ambient light, IR, and the UV. And when I bring closer the light source near the sensor, you can see the changes again. So this is how the sensor responds regarding Raspberry Pi and Java code. Now what we're going to do is to show the applications working which are relevant to these features and the benefits. The SI1132 is a low power ultraviolet index and ambient light sensor with I2C digital interface and programmable event interrupt output. This sensor IC includes an analog to digital converter, integrated high sensitivity visible and infrared photodiodes, and digital signal processor. The SI1132 offers excellent performance under a wide dynamic range and a variety of light sources including direct sunlight. This includes a wide range of applications such as fitness, health, electronics, tablets, smartwatches, smartphone handsets, display backlighting control, and a lot more to mention. This sensor can be purchased from the website, that is controleverything.com, and you can have the code from the resource tab, and after that you can download the code as a zip file. You can also have the code from GitHub repository, that is Control Everything Community, and you can download it from there. Now, in the end, I would just like to make it clear that at any point, if you have any further queries regarding any part of this video tutorial or the sensor, you can contact us on controleverything.com and put your comments on the community page of this website. For blogs and articles which are relevant to this sensor and video, go to our blog instructables.com, and to subscribe more video tutorials like this, you can have a look over our YouTube channel. Now, I hope you enjoyed this video and have a good one yourself. Thanks a lot for watching.